Welcome to Standex Electronics presentation on the exciting dramatic increase in automotive applications using hermetically sealed reed sensors. They are having a significant effect on automotive safety and adding to the overall vehicle intelligence. We will present the reed sensors technology and how they tie into the applications and show how they solve the application problems. We will also present many of the applications and go into detail on some of them. The hermetically sealed reed switch is the main switching component in a reed sensor and represents a unique technology unto itself. We will define its key functions and develop an understanding of its most commonly used terms. We will introduce the automotive sensing needs and how the reed sensors solve the many application needs. A reed sensor is composed of two key components, the reed switch and a strategically placed magnet. The reed switch may be directly mounted on a printed circuit board or wired to an electrical connector. The reed sensor is usually sealed and packaged in a plastic or metal housing. The reed sensors come in hundreds of different sizes and shapes to meet a host of different applications. The hundreds of packaging approaches offers uniqueness for each and every application. The reed switch is a small electromechanical switching device that has two ferromagnetic leads encased in a hermetically sealed glass cylinder. Ferromagnetic materials are materials that become magnetized when they enter or are influenced by a magnetic field. Iron, nickel, and cobalt are the most common ferromagnetic materials. The leads are internally aligned and separated by a gap. The reed switch can be as small as 4 millimeters and as large as 50 millimeters long. The sensing distance for a given application may be adjusted for optimum closing and opening to best suit the application. Here, the sensitivity of closures measured in millitesla or ampere turns. This is called the pull-in point. Removing the magnet, the contacts will open at some point. This is called the dropout point. Hysteresis is another useful parameter and can be adjusted to optimize a given application as well. Hysteresis is simply the ratio of the closure distance divided by the opening distance. The hysteresis can be critical for some applications, more on this later. Permanent magnets have a constant, non-varying magnetic field that has a north and south pole associated with them. In most applications, the magnetic polarity has no effect on the applications. The magnets come in different materials, rare earth, alnico, and ferrite. Several different sizes and shapes are offered having different magnetic strengths. The rare earth are the strongest. Alnico are the most stable, and ferrite are the least expensive. Magnetic strength is generally measured in Gauss or millitesla. The hermetically sealed reed sensors are ideal for under harsh environment conditions that typically exist in under-the-hood environments. Here, the dirty, corrosive, expansive temperature range, minus 50 Celsius to 150 degrees Celsius, has no negative effect on the reed sensor's operating characteristics. Reed sensors, unlike mechanical sensors, offer remote sensing at distances greater than 1 inch. Of course, non-ferromagnetic metals other than iron, nickel, and cobalt, and plastics offer no interference to their magnetic sensitivity. This allows the reed sensor to be placed in a benign environment out of harm's way. Reed sensors do not require any power when they are in their off or unenergized state, making them ideal for battery-operated applications. This is not the case with the solid-state sensors that need and use some power 100% of the time. Reed sensors are used anywhere where sensing movement is necessary. For example, hood or trunk closure, movement of the brake pedal, door opening or closure, key insertion, ABS brakes, speedometers, tachometers, cruise control, tire pressure sensing, door ajar, sunroof position, gear selection, emergency brake, gas cap placement, electric window position, security system controls, airbags, fuel shutoff, shock sensor, seat belt sensor, door locks, exhaust fumes emission control, and convertible roof end position. Yes, it's a long list and getting longer every year. Read sensors are also used anywhere where liquid levels need to be monitored. For example, brake fluid, oil level, fuel level, low fuel level, windshield fluid level, coolant fluid level, and transmission fluid. As additional fluids are added to the auto, read sensors will be added as well. Each sensing requirement for automobiles have a particular set of conditions that must be met. One must first examine the details of the application, determine the sensing technology, and then select the sensor that will get the job done. There are several sensing technologies that are considered for each application involving movement sensing. The most popular ones are solid-state sensors, mechanical sensors, read sensors, inductive sensors, and capacitive sensors. For each application, the automotive design engineer's challenge must be to determine the best technology. To this end, we will present some automotive sensing applications, list the requirements of the application, what technology was selected, and give the details behind that selection. Let's look into the application for a brake fluid sensor. When applying one's foot to the brake pedal, it is taken for granted that the braking mechanism will begin to slow or stop the vehicle. However, if the brake fluid is drained or leaked away, the brakes will not slow or stop the vehicle. The results could be catastrophic, with loss of life a possibility. So quality and reliability of any sensor selected to detect a reduction or low level of brake fluid remaining is critical. The operating temperature in an under-the-hood environment ranges from -55 Celsius to as high as 150 degrees Celsius. With a moving vehicle, the liquid can sway when turning or hitting a bump in the road. If the liquid is near the low-level sensing point, the sensor may energize, creating an alert of a fault condition. During vehicle swaying, the alert may come on and then go off repeatedly. A wide hysteresis built into the sensor will prevent this. Once the sensor is activated, it must remain on until the brake fluid has been added. Furthermore, like all plug-in electrical connections, the contacts can oxidize or corrode, interrupting the electrical connection, particularly in the under-the-hood environment. So the sensor must include the ability to let the onboard computer know that the sensor is properly connected to the electrical system. The hermetically sealed read sensor is the best choice and satisfies all the brake fluid sensing requirements. In this case, a float with an embedded magnet is placed within the brake fluid tank in an area where it can ride up and down with the brake fluid. The read switch is directly mounted to a printed circuit board, which also houses a high kilo-ohm resistor with 2 rugged terminals. These components are further housed in a plastic sealed package that locks into place in the lower external section of the brake fluid tank. The read sensor is plugged into a sealed automotive electrical connector, allowing connection to the vehicle electrical system. When the brake fluid level with the float is low enough, the magnet within the float will activate the read switch. The read sensor will then turn on an indicator light on the dashboard, alerting the driver of the low fluid level. The read sensor will then turn on an indicator light on the dashboard, alerting the driver of the low fluid level. It also turns off and alerts the operator the ABA braking system is turned off. Almost all the automotive manufacturers in the world have selected some form of read sensor for monitoring the brake fluid level. The read switch by itself is hermetically sealed, which guards against the effects from dirty, harsh environments. Because of these harsh environments and extreme temperature swings, some read sensor suppliers supply the read sensor in a vapor-sealed package for further assurance of proper operation in under-the-hood conditions. This is Standex Electronics' approach. Read sensors have the ability to operate for billions of fault-free operations. To ensure fault-free operation, Standex Electronics tests each sensor dynamically for thousands of operations on 100% of every read sensor that is sent to the customer. This dynamic contact resistance test has the ability to detect potential early failures which are eliminated from shipment. The reed sensor has accurate closure and opening points, which offers consistent, reliable operation over a long period of time. Furthermore, the reed sensor is easily able to adjust the hysteresis by offering a wide differential between the closure and opening distances. This prevents the rapid cycling of closing and opening of the sensor as the float rises and falls due to vehicle swaying. Standex Metter supplies their reed sensors on an electronic printed circuit board where all electrical components are soldered into place, unlike other manufacturers that supply their sensors with only mechanical connections. These mechanical connections can rust and corrode, potentially producing a faulty operation. Standex Metter also supplies a high resistance resistor that is also soldered on the PCB. This allows the vehicle's onboard computer to perform an ongoing scanning operation that monitors and ensures the reed sensor is properly plugged into the electrical system. The actual functional diagram of the reed brake sensor is shown above, where the float is riding on a full brake fluid reservoir. Pictured on the bottom of the reservoir is the reed sensor, which is electrically connected to a dashboard indicator and connected to the ABS system. As long as the fluid stays full, the reed sensor remains off and draws no battery power. Now in the diagram, the fluid level has dropped dramatically. The float is riding near the bottom of the reservoir and very close to the reed sensor. In this case, the reed sensor activates, turning on the dashboard indicator light and sending a signal to disable the ABS system. This then turns on a light, making the driver aware that the ABS system has been disengaged. The brake pedal sensor has become another important sensing requirement in the automobile where safety is a critical element. When applying one's foot to the brake pedal, it is taken for granted that the braking mechanism will begin to slow or stop the vehicle. The braking operation can occur hundreds of times a week, which can accumulate into many thousands of operations over its lifetime, all of which require flawless operation every time. Sensing the movement of the brake pedal is a critical first step. Any sensor on or near the brake pedal will need to operate 100% of the time in a dirty, sometimes wet environment. Since the braking operation occurs on the floor inside the vehicle, any sensor in the area will be subject to a very rough treatment. Mechanical sensors have been used in the past, but not being hermetically sealed, have encountered faulty operation due to contamination affecting their operation. The brake can have a lot of movement before the brake shoes actually engage. This gives rise to the need that a sensor sensing the brake pedal movement must have a very long sensing distance. Generally in the cab of the vehicle, the operating temperature is considerably better than the under the hood environment, but it can still range from -45 Celsius to as high as 60 degrees Celsius. The braking operation not only activates the brake shoes through a hydraulics system, but the sensor sensing the brake pedal movement must turn on the brake lights and disengage the cruise control. In heavy traffic, sudden stops can be the norm. Advance warning through the use of brake lights can give the operators behind just enough time for them to brake and avoid a rear-end collision. Similarly, if you are in cruise control and the need to brake arose, it's vital that the cruise control is disengaged. Otherwise, fuel would be continually dispensed trying to speed up the vehicle. Because of the criticality of sensing the movement of the brake pedal, it is vital that the dirty, wet environment have no effect on reliability of the sensor operation. Choosing a hermetically sealed reed sensor that is further packaged in a rugged plastic housing is essential for fault-free operation. Also, the reed sensor can remotely sense distances greater than 1 inch. This is important because the brake pedal can have significant movement to it. The sensing distance must be capable of maintaining its closure from the initial movement of the brake pedal to the end of its movement. In this manner, the brake lights stay on and the cruise control remains off. The reed sensor's wide operating temperature ensures reliable operation at the extremes in temperatures. This is not the case with some semiconductor sensors that not only require power 100% of the time, but also are derated at higher temperatures. The reed sensor does not draw any power until energized. Also, the reed sensor, having no wearing contacts, has the ability to switch billions of consistent fault-free operation over its lifetime, ensuring fault-free operation. The reed sensor has accurate, consistent closure and opening points, representing a crucial factor in reliable operation over long periods of time. Again, Standex Meter performs a dynamic contact resistance test on each sensor, which dynamically operates the sensor while monitoring contact resistance for thousands of operations on 100% of every reed sensor. This dynamic contact resistance test has the ability to detect potential early failures, which are eliminated from shipment. Mechanical sensors do have wearing parts that not only can become corroded, but can also wear out, resulting in faulty operation. Window washing on automobiles and trucks takes place with the operator simply engaging the turn-on control, usually mounted directly on the steering column in the vehicle. Automotive manufacturers have listed window washers are part of the overall critical safety system. This in turn means the sensor monitoring the fluid is critical where expected high quality and reliability is a strong requirement. The level sensor will need to operate 100% of the time in a wet, dirty under-the-hood environment. Mechanical sensors have been used in the past, but not being hermetically sealed, they have encountered faulty operation due to contamination affecting their operation. The sensor needs to be capable of operating as low as -55 degrees Celsius and as high as 150 degrees Celsius, and must be well sealed to handle the rough environment. The window washer pumping motor contains strong magnets that could affect any component using magnetic activation. Window washers, depending upon the vehicle, may require the fluid sensor be mounted on the top, side, or bottom of the fluid container. There are no standard packaging concepts currently in use for window washer systems. Side mounting sensors require anti-rotation devices, while all sensors require an integrated automotive connector. Sensors may require not only the sensing mechanism, but also include the magnetic incorporated float. In this case, the float mechanism would be mounted through a sealed entry within the fluid container. If the fluid is near the low level sensing point, the sensor may energize, creating an alert of the fault condition. During vehicle swaying, the alert may come on and then go off repeatedly. A wide hysteresis built into the sensor will prevent this. Once the sensor is activated, it must remain on until the washer fluid has been added. The specific gravity can vary depending upon the level of alcohol within the fluid. The specific gravity can alter the level of the position of the float within the liquid, giving rise to different turn-on and turn-off points. The switching mechanism needs to have the ability to switch incandescent and LED indicators as well as send signals to an onboard computer. Furthermore, like all plug-in electrical connections, the contacts can oxidize or corrode, interrupting the electrical connection, particularly in under-the-hood environments. So the sensor must include the ability to let the onboard computer know that the sensor is properly connected to the electrical system. The reed switch is hermetically sealed. Electromechanical and semiconductor sensors are not hermetically sealed. In many of the window washer sensing requirements, the manufacturers are choosing a turnkey reed sensor. This means that the reed sensor incorporates a sensing float that rides with the rise and fall of the liquid. It has an embedded magnet that will activate the reed sensor once the float comes within sensing distance of the hermetically sealed reed switch. The reed switch will, in turn, activate an indicator light and also supply a signal to the onboard computer. The hermetically sealed reed switch can also switch power, as well as very low-level digital signals directly. Electromechanical and solid-state sensing technologies cannot carry out both functions directly. They will need additional components, which adds more cost. It is vital that the dirty, wet under the hood environment has no effect on reliability of the sensor operation. Choosing a hermetically sealed reed sensor that is further packaged in a rugged plastic housing is essential for fault-free operation. On turnkey reed sensors, the sensors need to be locked in place, particularly when side-mounted to the washer fluid container. The reed sensor's wide operating temperature ensures reliable operations at the temperature extremes. This is not the case with some solid-state sensors that not only require power 100% of the time, but also are derated at higher temperatures. The reed sensor does not draw any power until energized. Also, reed sensors have the ability to switch billions of consistent fault-free operations over their lifetime. To ensure fault-free operation, again, Standex Meter tests each sensor dynamically for thousands of operations on 100% of every reed sensor that is sent to the customer. This dynamic contact resistance test has the ability to detect potential early failures, which are eliminated from shipment. The reed sensor has accurate closure and opening points that represent a crucial factor in consistent, reliable operation over a long period of time. Furthermore, the reed sensor is easily able to adjust the hysteresis by offering a wide differential between the closure and opening distances, thus preventing on and off cycling when the vehicle sways. Reed sensors can easily be designed for variations in closure and opening that naturally result with changes in float position due to changes in the fluid's specific gravity. Each technology has its own best operating characteristics. Reed sensors generally become the design and choice of most engineers when encountering wet, dirty, wide operating temperature ranges. Reed sensors continue to be selected for liquid level detection because of their favorable characteristics and versatile design capabilities over the other technologies. Those many automotive applications listed earlier all use the reed sensor basically for the same reasons presented in the three detailed applications.